All right, hello guys. So I guess this is the final part of arrays and hashing. Then, I wonder what I should choose. Probably two pointers. I like an idea of two pointers, but we can also go like half two pointers, half stack. A pretty good idea. But yep, I finally done. I know, but I think I've learned some things regarding arrays and hashing, such as uh the way you add it. You can add it from a hash set or append it from the array and stuff like that. Although, I really won't really remember the solution. The point here is that I should be aware on the tools I can use on how I would use it to solve future problems, especially when we go deeper down the rabbit hole. So let's finish the final ano. And I haven't watched the solution yet, but there's no preparation, but let's try to solve it on our own with a timer, of course. And if we can finish it within 10 minutes, then we will get to the solution. So, given an array of integer nums, return the length of the longest consecutive sequence of elements. I think I've done this before in lead code, but of course I don't remember. A consecutive sequence of which each element is actually one greater than the previous element. So, two, one, here's one. One, what? The longest consecutive consequence, two, three, 4, 5. Okay, as long as it's this one. 1, 2, 3, 0, 1, 2, 3, 4. Okay, okay. Given the rare, then the length is the longest. That's twice. So rest was 0. So, or num and num. We can num that sorted. That's a function, right? Num dot sort. But no, it's not. Bye. Dot sort. Nah, that's not how it works. We could try hashing again, and then within that hash set we iterate those that we start from the lowest. But then again, that's gonna be a bit quite long. I can imagine the O of n complexity here. Hmm. We could also check if it is no, because it's not necessarily needs to be in a sequence, and it should be the length. I guess we should check out the solution. No timer now. I guess we've had enough. So let's check out the solution now. No, oh, good
Let's
for
solve LeetCode 128 longest consecutive
sorting
sequence.
hash. See, I told
This
you
is a
hash.
pretty
Oh, a
interesting
hash map.
problem, and it's actually been asked by a lot of
Let's
companies,
watch it.
including Google, for coding interviews, so I think it's a good
Wait,
problem to
this is a
understand.
video?
So we're given an input array of numbers, right? In this case, we have 6 numbers, and we want to find the longest consecutive sequence. In this case, the longest consecutive sequence is 1, 2, 3, 4, right? It doesn't matter what order the numbers appear in the
In
input
there.
array, we just want to know the longest consecutive sequence that we can make from the input array. Now, the most obvious way to solve this problem is just by sorting, right? So if you look at the
Hey,
sorted
I want
array
to see
over
the
here,
brute
we
force.
have obviously
All sort of in a set inside of noms for noms. Streaker. It's gonna check a streak and then current is 0 num. While current store streak plus equal current plus equals 1. Rest equals maximum. So it's gonna get the maximum of rest, which is following the streak. If I'm right. Wait, yeah, but nah, not that brute
one
force.
consecutive
Because it's
sequence of length 4, right?
very
1, 2, 3,
time
4. They're all
complexity high.
consecutive numbers. We also have another one that's length 1, just 100. And we have the last one that's also length 1, just 200, right? Now, this is definitely a valid solution. We can definitely code this up, but the time complexity is going to be O n log n. So
Yeah,
the question is, can we do better?
the n
So
is
this is a LeetCode
the
hard.
sorting and then the
Obviously, the solution wouldn't be this simple, so we can do better. But how do we get there? Now,
hash
the
map.
first thing to do is try to visualize the problem in a way that it makes the problem really easy to understand. So I visualize the problem by drawing out an imaginary number line, right? So we can kind of see what the sequences actually look like. This makes it a lot easier to recognize the patterns. So we know we have one sequence that starts at 1, 2,
Okay,
3, and 4. We have
no.
another sequence that comes after it with just one number, 100.
Okay,
We have the last sequence with also only one number, 200.
100.
So just by looking at it, we can
So we're
tell we
gonna
have
sort them
3
based on
distinct sequences, right? That's something to recognize. Now, by visualizing it, we can kind of try to approach how would a human solve it? Well, the easiest way is just look at each of the sequences, right, and count how long they are. So let's look at the first sequence, right? We have 1, 2, 3, and 4. So this sequence has 4 numbers in it. We have the second sequence, just 100, so it only has one number in it. So it's a sequence of length 1. The last one is also a sequence of length 1. Now, this is
uh I think I have an idea with making you can try a try as well. Because that's pretty cool. A try is also doable, but I'm not sure if that's how often because you can like make conditionals where it's greater than but yeah, that's the problem. You need to add a parameter where like maybe the lower end are bigger, but I mean that's just an interesting idea because I haven't seen the software. But just noting it's probably not possible because I don't know. It's either possible or not. I haven't done it anyways. It's just an idea.
so easy to solve when you visualize it and try to approach it how a human would. But can we actually convert this into code somehow? The answer is yes. So the
Probably not. The try wouldn't work because there's no input parameter inside that you're not gonna. It's just a list. You can't like get
most important
can't like somehow get the median of the list somehow.
thing to notice is that we have 3 sequences, but how can we identify what makes a sequence? How can we actually start at the beginning of a sequence? The thing to notice, and this is really easy when you actually look at the picture, that each sequence has a start value. The start value, in this case, the start value for the
One.
first range or the first sequence
What?
has no left neighbor. The first value 1 has no left neighbor, right? That's really obvious. Look at the second range, 100. It doesn't have a left neighbor. The third range, 200, doesn't have a left neighbor. So we can get the start of each sequence by just looking at our entire array of numbers, right? And figuring out which numbers don't have a left neighbor. So meaning
Okay.
if we wanted to check if 1 had a left neighbor, we would check does our array contain the number 0? If we wanted to know if 100 had a left neighbor, we'd check does the array contain 99? The easiest way to do this and the most efficient way to do
Hush
it
set.
is by taking our initial array and converting it into a set.
Haha.
So now to
It's
find the
probably not
start
a hash
ranges,
set.
let's
Just a
start
set.
iterating through our array. So we get to the first element, 100. Does it have a left neighbor? Well, we can check our set. It doesn't have 99 in it. So this is the first so this is the start of a sequence. So let's get the length of the sequence. We start at 100. Now to
Oh,
get the
this
length of this
interesting.
sequence, we want to count
So if we check that 4, but it's not checked yet. But
how
yeah.
many consecutive numbers come after 100. So we want to know, does 101 exist in our sequence? Looking at the number line, obviously it doesn't, but how can we check this efficiently with code? Well, we already have a set that takes up this entire array, so let's just use our set to check if 101 exists. Since it doesn't, we can no longer continue this sequence. So now we get to the next number.
Okay, so the set basically makes it so it takes everything here instead of it like one by one putting it. So it's not a hash set or a hash map. So it's supposed that 4 will know one will know that there's a two, and two will know there's a three, and three will know if there's a four. And four can also check its previous one, which is three, I think. But yeah.
4. Is 4 the start of a sequence? Let's look at our picture we drew. 4 is not the start of a sequence, and we can check this using our set. We would check that it does have a left neighbor, right? 3. So it's not the start of a sequence. We're not going to make...
Okay, okay, now I get it. So we're finding it by the left pointer. If it's null, that means that's a starting point, and we give it a value of one, and then we go do, and that's four.
a range from it. We get to the next number, 200. Is this the start of a sequence? Looking at our picture, yes it is, and we know that 199 does not exist in our set. So let's make this sequence. Let's try to make it as long as we can. We check, does 201 exist? No, it doesn't. We can tell that from our picture, and we would use the set to determine that. So now this is as long as we can make this set, so let's get to the next number, 1. Is 1 the start of a sequence? At our picture, we can tell 1 does not have a left neighbor, so it is the start of a sequence. Now let's check if 2 exists in our set. It does, so we can make this sequence a little bit longer.
Oh yeah, is the set automatically sorted? I don't know.
Now let's check if the next number, 3, exists in our set. Yes, it does, so let's make it even longer. Now, does 4 exist in our set? Yes, it does. Now let's check if 5 exists in our set. It doesn't, right? There is no 5, so we can't make this sequence any longer. So now let's continue through the array. 3. Is 3 the start of a sequence? No, it's not. It has a left neighbor too. Now let's try 2. Is 2 the start of a sequence? It's not, because it has a left neighbor 1. So we went through the entire array. We created all the sequences we could. The first sequence is length 1. The second sequence is also length 1. The third sequence is length 4. So this is the longest sequence. Now we took a really complicated problem, or seemingly complicated, and we broke it down so easily. All we had to do was iterate
Epic.
through the initial array, use a set, and check if values had left neighbors, and if they didn't, then they were the start of sequences. We made this problem so easy with only using one data structure.
Wow.
Since we only had to iterate through the entire array and we had to expand each range, we know that we're only going to visit each number at most twice, so our solution is very efficient. And we did have to use additional memory to create a set, because we wanted to check if neighbors existed. So for the memory complexity, it is also big O of n.
Okay,
In this
so it
case,
doesn't have
n
to
is
be
the size of the input
sorted.
array. So now let's get to the code.
Just checking like the bigger by one.
Remember, we need to create a set from the initial array nums. So it's really easy to do that in Python. We can just pass the array into a set constructor. Next, we want to keep track of what the longest consecutive sequence is. Initially, we can say it's 0. So we want to iterate through every number in the nums array. And we want to check if it's the start of a sequence. And we can check that simply by checking if n minus 1 does not exist in our num set.
Okay.
If this number doesn't have a left neighbor, that means it's the start of a sequence.
It's the start of a string.
So now we want to get the length of this sequence. Initially, we can say the length is 0. And we want to keep getting each consecutive number and checking if it exists in our num set. If it does, then we can keep expanding the length. So initially, I'm going to check n plus length, because that's going to check the current number. Initially, length is 0, so we're just checking the current number. As the length grows, we'll check more consecutive numbers. At the end, we could have potentially found the longest sequence, so we want to potentially update our longest by just taking the max of the current length we just computed, as well as what the longest originally was.
Okay, so this one's basically takes a parameter of max from the length of the longest. So length, longest. Okay, so once we get the maximum length, but only for the parameter of longest. So if this is 5 and the longest is still 5 and we get the 4 length, it doesn't give 4, so it doesn't get replaced the longest, if that's my
Max of the
understanding.
current length we just computed, as well as what the longest originally was.
Yeah, or the original, no, max between these and these. So if this was 6 and the old longest, let's say you get up another 5. Now we got 6.
And it's really that simple. So now all we have left to do is just return what the longest the longest sequence was that we just computed. So we did this in such a small
Really? While it's checking if while the n plus length is inside of numset. So while n plus the length is 0, n plus 0. So it's currently pointing at index 0 at its current location. It's gonna say, okay, now we found this in numset, so that means it's 1. Now we use n plus 1 in numset, while n plus the right one, then if that one is n plus length, that means while n plus 1, so that means 1 plus 1, 2, is if 2 is inside of numset, then we add up n again. So length plus equals 1, 2. So if 1 plus 2 again is in numset, so in that idea 3. Okay.
amount of code. Now let's just run it to see that it works. And it works perfectly. So this is a linear time solution and a linear memory complexity solution. Once we visualized the problem, the solution became so easy to derive.
Wow. Shia LaBeouf. And what the it is a hash set. What the hell? What the hell is this shit? If not, no. Nah, I ain't doing the hash map. Okay, let's go. We can now do it. I forgot everything that was teached upon me. But let's go. I swear it's nums. And num set of the nums. Okay. Now after we create a set inside the num set, I assume we're gonna for n in noms. Now we're gonna make a for loop now, right? I keep peeking. No peeking. No peeking. Yeah, timeout. I'm just gonna the timeout is watch one short.
LeetCode is more difficult than just what I've talked about here. Some problems are definitely more difficult than just taking something and applying a core algorithm to that problem. I think the next level of getting good at this stuff is asking the question, why does something work? Most people think math is just memorizing. What math really is being
Yeah,
able to argue why the math works in the
and why it
first place.
doesn't.
You might have taken a discrete math class in college or some other class where you had to do math proofs. This is kind of the second component to LeetCode problems. You might have looked at a LeetCode solution or watched one of my videos. Even though the algorithm made sense, it might have been an algorithm you're familiar with, you still didn't fully understand
Yeah,
why it worked. If you want to be able to solve a problem for the first time, you have to really understand why. What I'm getting at is it's not just about being able to quickly write out the DFS algorithm or BFS algorithm from scratch. It's about understanding exactly why it works. LeetCode is more difficult than just what I've talked about here. Some problems are definitely more difficult than just taking something and applying a core algorithm to that problem. I think the next
what
level
the hell? It's just looped out. Okay. We should have forgotten everything now. Yeah, I already forgot everything. So, so what was done the solution again is uh uh we're gonna create a longest, so we're gonna get the longest current for n in noms. We're gonna check if net n is not in num set. If it's not in the num set, that means we can now initialize this. This is the longest length. This is the longest length. We don't want to get confused. So if n is not an offset, we now can create a temporary variable called length. Yeah, just I think that's fine. We don't need to give it a zero, but no, we need to give it a zero. That's what I know. So now if n not in num set, length equals zero. So now since no, if n minus one, right? No. So if no, if I'm sure it's fn minus one, like it's pointing to the left. Because if that right, yeah, yeah. Oh fuck, it's actually not num. It should be num set. Oh my god, stupid ass. Dumb ass. So if n minus one, so now we're at like so it's iterating over the set, literally. If n minus one is not a num set, which means no. It's not like an array, okay? You can just imagine it. If let's say one, and if you point to the one, there's no zero to it. It's like an imaginary pointer. Like it doesn't have to be an array. The array given by needful is like just more of a so that you don't get confused. So if n minus one is not inside of the num set, then we assign it we initialize a variable called length. Then we're gonna now check if if the current if the current n plus length is in the num set, then we append length plus equals 1. Yeah, that should be correct. Sorry, because it's gonna be pointing inside the num set in its own. So it starts first in n plus 0, so it points to itself first. So plus equals 1, then we repeat again. And now, after this, we're supposed to now get the max, right? No. It's supposed to keep going. One, two, three. No. Longest length. Now get the maximum between lengths and longest length. Now we can return length. Nah, there's probably something I'm missing here. It's not gonna work. Trust me. I told you there's something wrong with the code. Let's see why it doesn't work. Let's try to check our epic logic. So, hmm, I swear there's something wrong. I'm missing something here. Let's see. Let's see what we're missing. Oh, it's not an if. Oh, it's supposed to be a while loop. I swear I noticed that because if it's if, I was wondering if then it should now go back and like, yeah, it's a while loop. Now this should work now. Just change it to while and it works. So dumb. Well, again, thank you for watching. This is hashtag 9 longest consecutive sequence. Thank you.